what we have seen that there are a number of applications, and some of them are something which we're going to discuss. So if you basically consider an inverting amplifier and a non-inverting amplifier, the basic difference is the terminal across which you are actually providing the input. So if you consider an inverting amplifier, you're putting it in this negative terminal, in the non-inverting you're putting in the positive terminal. Okay, something we should note is the voltage gain. Okay, and if you are basically considering an inverting terminal, the voltage gain is basically nothing but minus of RF divided by RI. Okay, so that's there. And if you basically consider this, and then you can actually solve some numerical. We have actually solved this particular problem. Okay, and in the non-inverting amplifier, we have got the gain as this. Okay, so whenever you're doing any kind of numerical, you have to check whether it's inverting or non-inverting, and based on that, you have to just do your calculations. Okay, so we will actually just look into multi-stage op-amp circuit now, and there we need to know what is the gain of the inverting amplifier and what is the gain of the non-inverting amplifier, and then we are basically going to combine to get the total gain. Okay, and then I have given you this question, although I'm not going to solve it today, but then maybe I can give you the final answer here. Okay, anyone got the answer for this? The answer for this is basically 12 volts. Okay, so the answer for this particular question that you should get is 12 volts. So all of you, even if you have not done, I'm sure some of you have done it. If you have done it, you should get 12 volt. If not, please do it. Okay, so that's important. I'm not going to discuss the question today, and we will start with something which we call as the multi-stage amplifier. Okay, so multi-stage op-amp circuits rather. Okay, we're just going to talk about more than one op-amp connected. Okay, so it's a very basic idea. We're just going to talk about the gain here. Okay, and the gain is easy to understand now because you already know that what will be the gain for an inverting and a non-inverting circuit. Okay, so when we talk about multi-stage op-amps, it basically means that we have got a number of op-amp, okay, which are in series. Okay, they are connected one after the other. The gain of one amplifier will be an input to the next op-amp. Okay, so you know, in this particular unit, whenever I say op amplifier, I usually refer directly to op-amp only. Okay, not any other kind of amplifier. Okay, so overall voltage gain. Okay, overall voltage gain is basically equal to product. Okay, of the individual stages. This is the basically the overall voltage gain. You take individual stages, you multiply them, and then you get the overall voltage gain. Okay, so maybe you are having some gain in the first stage, and let's say the first stage is basically, let's say it's a non-inverting gain. Okay, so I'll just take an example here. Okay, and this is a helpful for solving problems. It will basically provide let's say a non-inverting gain. Okay, so it's going to provide you a non-inverting gain, and for that, what is the gain? We already know it. Okay, we're just going to write it down later. And let's say we have got another stage, which is the second stage. Okay, and in the second stage, let's say it again provides, let's say, inverting gain. Okay, so let's say it provide inverting gain. Okay, it's going to provide you an inverting gain. And then finally we have, let's say, have got one more stage. Okay, it can be more than this, but we're just taking example of these three. Okay, and then this also provide inverting gain. Okay, inverting gain. Okay, so in general, if you just want to find out what is the total gain, you're just going to multiply that. Okay, so what happens usually is, if you're getting any kind of numerical problem, first you have to check whether it is inverting or non-inverting. So if it is non-inverting, this would be 1 plus RF by R1, right? Because there are three op-amps connected, so I'm just not writing down other values. I'm just writing down R1, which represents the resistance connected to the first op-amp. Okay, R2 is with the second one. So for the second one, since it's inverting and not non-inverting, okay, it's not non-inverting, it's inverting. So for an inverting one, we basically have minus of RF by R2, right? RF by R2. and for the third one we have got again RF by R3. Okay, so if we just go back to our previous page, okay, maybe here, you remember this, right? This is your non-inverting amplifier, and this is how the circuit looks like. So you have got Ri and you have got Rf here. So we are taking three, so we are taking R1, R2 and R3. So this R1, R2 and R3 are taking the place of Ri in each of these amplifiers, okay? And you see, if you are taking this non-inverting amplifier which has got a gain of this, whatever is the gain here will be the input to the next op amp, okay? And this is what is multi-stage is all about. So it's simple, right? So this is there, and then if you actually want to find out what is the total gain, you're just going to multiply it. So if you want to find out the total gain, it's nothing but A1 into A2 into A3. So it will be A1 into A2 into A3. That's it. Okay. So this is the gain of the op amp which is having multiple stages. Okay. But you know, op amp actually can be used for other purposes as a mathematical tool. Okay. So basically, it's nothing but acting as a uh, adder or a subtractor, okay, or an integrator, okay, or a differentiator and so on. So we are going to just discuss that part now. Okay, so if we just consider op amp, okay, it's basically we have the two topics that we are going to discuss now is number one as averaging amplifier. That's the first one, and the second one is as subtractor. So you know, if you are having two different voltage sources, we can use it as a subtractor. If you are having a voltage source across a series resistance, we can actually take an average of it, and these things can be done using an op amp. Okay, and this is something which we are going to discuss now. Okay, so let me just box this. This is a different topic. Okay, and then now what we're going to do is something which is different again. Okay, so if we talk about an averaging amplifier, first let me just draw the circuit, okay, and then we can actually move. So the first thing is as averaging amplifier. Let me just adjust, okay, so that everything looks arranged to you. It's important that you understand it clearly, okay. So number one, we are taking as averaging amplifier. So we are using it as an averaging amplifier. So you know, electronics, you do a topic, you basically have to draw the circuit, okay. So what usually I used to do is during my college days, whatever may be the topic, I will draw the circuit first and then probably I'll do the theory part and everything else. So I'll just continue with that trend. I'll probably draw the circuit and then probably we can explain it, okay. It's not going to be very difficult. So op amp, so we are going to do whatever we already know, okay. Just going to have the resistances and everything else connected, okay. And then here we are going to connect it with the inverting terminal, okay. We want to connect it with the inverting terminal. This is your non-inverting terminal, and if one is connected, the non-inverting terminal will be earthed, okay. So as we keep on drawing, these things should be coming to us easily, right? And what we are going to do is we are going to have three resistors which are basically connected parallel to each other, okay, and all of them has a common connection with the inverting terminal, okay. So all of them has got a common connection with the inverting terminal. So maybe this is the voltage across the first resistor, this is the voltage across the second resistor, and this is the voltage across the third resistor, okay. And we have got the negative terminal here and we have got the positive terminal here, okay. So let's try drawing the resistors now, okay. So in general, when we talk about the output, we are always going to consider a resistor here, and that is your RF. So this will actually more or less remain the same, right? So this is your RF, and then at the input, since we are talking about adder, we are actually going to add not adder, average of three different values of voltages. So let me just draw 3 resistors here. Okay, so if I'm drawing it and if you're doing it at the same time, I think it will be a good practice. There are certain conditions based on which it will act as an average amplifier. Okay, I'm just going to define that condition. That condition is usually not defined in the diagram, but because diagram whatever I've drawn is not that good. Okay, so this is, we are having basically 3 voltages here. Okay, basically V1, V2 and V3. Okay, and let's say this is your R1. Okay, and we will assume R1 to be 3 ohm. This is your R2, and although it does not look as same as the previous one, but this is also 3 ohm. Okay, and then finally this is R3, which is again equal to 3 ohm. Okay, if you are watching this on your mobile phone and if you pinch in or pinch out with your 2 fingers on your mobile screen, you can zoom into this. Okay, so you can use that feature of Microsoft Teams as well. Okay, so I will take the output across this V out. Okay, so we have this, and let's say this RF is quite high, 1 kilo ohm. So this can be an objective question. See, this RF load resistance is usually very high compared to the input resistance. Okay, so previously we have already seen this to be nothing but Ri, but in place of Ri we are connecting 3 resistors parallel to each other. So remembering this circuit should not be a very difficult job. Okay, should be more or less okay for you. Let's just do certain calculations, but before that, if you want to use it as an averaging amplifier, we basically need to have certain conditions that needs to be fulfilled. Okay, any circuit cannot be used as an averaging amplifier, certain conditions, and one of the condition I think is already visible to you. Why these 3 resistors are equal? They should be equal. Okay, and why it is 3, that is, there is also a reason for this. Okay, so this is the condition that we are going to just look into. Okay, so the first condition is all input, okay, resistances are equal in value, equal, okay, in magnitude. So we basically say R1 is equal to R2 is equal to R3. Okay, and just level that later. And then there is one more condition, ratio, okay, of any, okay, maybe R1, or you can take R2, or you can take R3, okay, input resistor. This is an important condition, you have to note it down, probably this can be a part of your question. Input resistor to the feedback resistor, okay, is equal to number of input circuits, so before I explain this, let's just complete this whatever we have written. Okay, so we have it as R1, R2 and R3. So you see how many circuits are there. Basically it's basically, if you consider individual resistances, you are basically having 3. Okay, so you have going to have 3. So what happens is ratio of R1 or R2 or R3 input resistor to the feedback resistor. So that means we are talking about R1 by Rf. Okay, so if you just take the ratio here, okay, just look into this as a ratio. Okay, okay, I think I made one mistake. Yeah, since this is an op-amp, we are really not going to talk about the high value of the output impedance. Sorry, this is not ohm, this is kilo ohm. Okay, otherwise the entire definition goes wrong here. Okay, and sorry, that's again wrong. It's like the output and the input resistances can be comparable. Okay, it's not that it should be very high. This is okay, this is kilo ohm. Okay, else the ratio doesn't make sense. Okay, this is kilo ohm. So when we take R1 divided by Rf, okay, this is 3 divided by 1, which is 3. Okay, and you know there are 3 resistors. Okay, there are R1, R2 and R3, and it is forming 3 input circuits. So this is what is meant by this second condition that we are talking about. Okay, and based on this we can actually find out what is our V output. Okay, and let's try to find out what is V output. So if we just want to calculate V out, all of them are connected to the inverting terminal, and if you remember, for an inverting terminal it is minus of Rf divided by the resistance. Okay, so we'll just take the minus sign out, and within bracket maybe we can put the other values. So what we can do is we can take Rf divided by R1, Rf divided by R1, and then we are measuring voltage. Okay, so whatever may be the voltage at that particular point, so it is V1, so this voltage here, this voltage, and then plus, okay, Rf divided by R2, that's the ratio, pure ratio, V2 plus Rf divided by R3, 3 into V3. So we have already considered the value of the resistors, okay, and of course what is the ratio. So you can just replace these values. So you see this is Rf by R1, this is R1 by Rf. So Rf by R1 would be 1 by 3, right? So you can just take 1 by 3 here. This would be V1 plus 1 by 3 V2 plus 1 by 3 V3. Okay. So if you just take this as minus, you can take this to be the average of V1 plus V2 plus V3. So you see whatever is the output voltage, okay, this is nothing but this V1 plus V2 plus V3 divided by 3, okay, and that is why it is basically called as the averaging amplifier. So you have got 3 different voltages, whatever is the output is the average of all these 3. So if you're basically having a circuit and it is connected in such pattern, you are going to get the average of all the 3 voltage sources, okay, and that is what is called an average amplifier. Next we are just going to look into the op amp as a subtractor. Okay, so let's just have a look at that as a subtractor. So number 2 is subs. So let's draw the circuit, right? So what happens is you are going to actually draw 2 op amps now. Okay, so in order to do this, let's draw 2 op amps. No point copying the previous one because it's kind of different here. So I will quickly draw it, okay, then maybe I can explain it better. So you're going to have 2 op amps, and when you draw it, draw one op amp, and then after that take the input to the negative terminal of the next op amp, okay, so that when you draw it you don't miss it out. In case you're drawing it with a pen, you cannot keep on making the corrections, right? And then finally you are going to get the output across this particular end. Okay, let's just do this here. Okay, so here we are just going to apply input across the inverting terminal, okay, and then here we are going to get the input. So this is something you may draw. If you don't draw, it's fine. Okay. Then we need to have one RF value. Okay, so in fact we are going to have got 2 RFs here. Okay, so we need to have an RF here also. Okay. Let's complete it part by part. So what happens here is basically you are going to have a resistor here, okay, as usual. Please don't mix up the circuit when you are doing it in your exam. Okay, this is your RF1, let's say it is RF1, okay, and let's say this is RF2. Okay, and this is your negative terminal. Okay, this is your negative terminal, this is your positive terminal. Okay, then we do have an input resistor here also. Okay, And then we have got input voltage, let's say V1, okay. And this is your R1, let's say, and let's say this is your R2, okay. I will give some values to it. This is RF1 and this is RF2, okay, and let's say this is 10 kilo, okay, and this is also 10 kilo, and this is also, let's say, 10 kilo. So we are just putting the values as 10 kilo ohm for all of them, okay. This is 10 kilo ohm. So the output of this will be an input to this op amp, okay. This is something which can be seen, okay. And you know, this particular point, the voltage is minus V1. I will tell you why it is minus V1, okay. You know, at this particular point we are also going to look into the voltage, okay, and then finally we are going to get the V output here. So this minus V1 will be the input to this, okay, and this V1 is the original input that you had. Whatever is the output here, you're going to get the input at this particular transistor, okay. And this is how a subtractor circuit will actually look like, okay. So if to just look into this, okay. So if you just look into V1, okay, it is basically applied, okay, to the standard inverting to standard inverting amplifier, okay. That has unity gain. So the gain that we are talking about here is actually 1. So you are going to apply this to this particular amplifier, okay, and this has got basically a unity gain, okay. So what happens is you are basically going to have an output from here, okay. So output from inverting amplifier is equal to minus V. Inverting amplifier is equal to minus V. I think it's quite obvious. I'm not going to apply any kind of voltage here, right? This is earth. So that means this is 0 and this is V1, okay. So it is going to be nothing but V1 only. The difference is V1, that is going to get amplified, but it's at the inverting terminals we are going to get minus of V, right? So that is minus of V. Let's denote it as V1, right, since we have written the 1. Now if we actually want to take the output, okay, so this output is basically applied to the uh, amplifier, okay. So basically what happens is uh, this is an input, so V out is equal to, so let's say these are the two amplifiers, right? Let's say this is one op amp A and this is the second op amp B. The output is again going to be a negative one because you are applying it to the inverting terminal. So I'll just straight away put V minus, and then I will just simply write it down as VA, whatever is the voltage from A I get, plus VB. Okay. So if you take it that way, we can just simply say this minus, and this is minus of V1 plus of V2. Okay. So V1 is this because of this amplifier, and V2 is because of this amplifier, and the minus sign because of V2 we have already considered it here, okay. So understand this. So that means if you just take it simply, it is going to get it to be V1 minus V2. So we are basically subtracting two voltages, so you can actually find out the difference between these two voltages, right? The idea is simple. Basically, if you are basically having two, let's say something which you already know, two resistors, okay, and let's say the voltage drop across this is V1, the voltage drop across this is V2. If you want to find out what is the voltage drop across this is going to be V1 plus V2. That's the total voltage drop. So that is what is happening here, okay. We're basically going to find that out only, V out, and that's why we are just adding up the voltages. But the voltage from the first part is minus V1, the voltage from the second part is V2, okay, and because it's an inverting terminal, I put a minus sign here. So now if I do my calculations correctly, I should get it to be V1 minus V2. And this is why it is basically called as a subtractor.